This video will cover the 4 interval types used in analyzing post-tonal music. Just like in tonal music, intervals in post-tonal music are defined by the number of half steps between 2 notes. Each interval type will fall into a category of either pitch or pitch class, and then further subdivide into ordered and unordered categories. Altogether, these categories make up a total of 4 interval types. Let's begin with ordered pitch intervals. This type of interval shows us 2 things. First, because pitches are register specific, pitch intervals show the number of half steps, or the absolute distance between 2 notes. Since they are ordered, the second thing they show is what direction the interval is going, using a plus sign for ascending or a minus sign for descending. This type of interval is useful for analyzing contour.
Let's look at some examples. When counting half steps, I find it easiest to use a clock face.
In this first example, the interval is ascending, so starting with pitch class 5, count the half steps to 0 going in a clockwise direction. Here, the distance between pitches 5 and 0, which equals 7. But what if the interval is greater than an octave? Take this example. Again, start on pitch class 5 and count in a counterclockwise descending direction. Since this interval is displaced by an octave, which contains 12 half steps, simply add 5 plus 12. And since this interval is descending, it gets a minus sign. But when using the clock face method, always count clockwise for ascending intervals and counterclockwise for descending intervals. The next type of pitch interval is just like ordered pitch intervals, only simplified. When 2 notes sound simultaneously, they do not have a direction, so we use unordered pitch intervals. Just like ordered pitch intervals, these show the exact number of half steps between 2 pitches, but they have no sign for direction. In these examples, the unordered pitch intervals are 7 and 17. Using the clock face, just like with ordered intervals, if you start on the lower note and count up to the top note, go in a clockwise direction. Or if you start on the higher note and count down, go in a counterclockwise direction. Moving on to our category of intervals dealing with pitch class, let's begin with ordered pitch class intervals. Since these are pitch class intervals, the mod 12 function will keep the integer between 0 and 11 and share the properties of octave and enharmonic equivalence. Ordered pitch class intervals are most easily calculated using a clock face. First, we'll assign letters to the pitches in question, x for the first one, y for the second one. In this example, x is pitch class 11 and y is 8. Always begin on x and count in a clockwise direction to y. To express it algebraically, use the equation y minus x mod 12. Using the equation for the same example, 8 minus 11, negative 3, mod 12 equals 9. Our final interval type is called unordered pitch class intervals, or more commonly, interval classes. These intervals will be from 0 to 6, showing the shortest possible distance between 2 pitch classes, regardless of direction. Learning the complements of all pitch classes will help speed up this process. Complementary pitch classes are 2 pitch classes that sum to 12, like 1 and 11, 2 and 10,
etc.
On a clock face, you can identify the interval class by counting half steps in both clockwise and counterclockwise directions, and then choosing the smaller number. The algebraic alternative uses the same equation as ordered pitch class intervals, y minus x mod 12, and compares the answer to a second equation, x minus y mod 12. Applying these to the example, we will get 9 and 3, which are complementary in a 12-tone system. Of the two, choose a smaller one falling between 0 and 6. Thanks for watching.